Okay, let's move into this next section, known as factoring by special products. Now here's the deal with this section. This section is basically the same as the previous lecture I did on factoring trinomials. So if you understood how to factor trinomials, you're going to understand what we're doing here as well. So there's not a whole lot of difference. In this particular video lecture, we're going to have, shall I say, a couple of observations. That's really all we're doing. Got it? Okay, so let's look at this first one. So, based upon the previous lecture, you're going to see if you can reduce. Can't. Is it in descending order? Yes. And then what do? We take the first and multiply by the last. So the 4 is going to get multiplied by the 9, which gives me 36, right? Okay. Now, I'm supposed to list all the combinations that multiply to a positive 36. Now, 36 is not that large of a number. However, here is the observation. So, paper and pencil ready? The observation is this. The first number was a perfect square. The last number was a perfect square. And when you multiplied those together, you got a perfect square. The observation is this. The combination that you're looking for, a good 99% of the time, is the square root combination. What's the square root of 36? Yeah, 6. So it's either 2 positive 6s or 2 negative 6s. And good 99% of the time, one of those two combinations is the one that's going to work for us. Does one of those work for us? Yeah, the 2 negative 6s, right? Because the 2 negative 6s will add to that negative 12 in the middle, won't they? Here's the deal. The observation is when the first term and the last term are both perfect squares, they will definitely multiply to a perfect square, and the combinations you're looking for are the square root combinations. In this case, 6. So it's either 2 positive 6s or 2 negative 6s. And the combination that worked was the 2 negative 6s. Okay, so found the combination. We can take it from 3 to 4 terms, right? So what's it looking like? Good. It is looking like 4x squared minus 6x plus 9. And now that you got 4 terms, break them apart. Excellent. So we're going to group them. We're going to pair them up, right? First 2 and last 2. What comes out of the first 2? Good, a 2 and an x. And out of the second 2, definitely a minus sign because that first term is negative. Good, a negative 3. Excellent. So, take out the 2x. What remains? Well, out of the first pair, you have a 2x minus 3. Wonderful. Out of the second pair, you took out this minus 3. What remains? Negative 6x divided by negative 3. Good. Positive 2x. And a positive 9 divided by a negative 3 is a negative 3. And, yep, you got it. It looks like the 2x minus 3 was distributed to another 2x minus 3. Cool. 2 of a kind, so to speak. You could also write this answer as the quantity of 2x minus 3 squared. You're like, what's that word quantity mean? It means parentheses. So the quantity of 2x minus 3 squared. Cool? Okay, I got a little change on the second one. All right, so here's the deal. Wow. The second one looks like fun, but no, we can handle it. All right, remember, reduce it first if possible. Can you? Yeah, nothing goes into those 3 numbers and there's no variables in common. Is it in descending order? Sure. X squared, x to the first, no x's. We're good. So how do you start? Yeah, you're supposed to take the first number, which is 16, and multiply it by the last number, which is 49. And when you multiply those two together, what do you get? 784. All right, that's a really large number. But I'm noticing something. The 16 is a perfect square. The 49 is a perfect square, which means the 784 is a perfect square. So what's the combination you're going to try? The square root. So tell me, what's the square root of 784? I know you have your calculators. Good, 28. So we have two 28s, right? Both positive or both negative. Whoops. Because both of those will multiply to 784. And excellent. Woohoo! This is why the observation is so nice. I'm noticing the two positive 28s give me the positive 56 for the middle. Right? Yay! Thank goodness for observations. Again, perfect square times perfect square gives me a perfect square. And 99% of the time, it's the square root combination that's going to work for us. I don't have to bother writing all the rest of them. Cool? Okay, so let's see what this looks like then. Yeah, we have 16x squared, then what? Good, positive 28xy, wonderful, and another positive 28xy, awesome, and then the positive 49y squared. Okay, we went from 3 to 4 terms. Excellent. Now what? Break it apart. Okay, so first two, and then the last two, right? So anything in common with the first two? Yeah, out of a 16 and a 28, I can certainly divide both by 4. And I'm noticing that both of them have an x in common. Good? Okay. The second pair, I know that I'm taking out a positive number because the first term in this pair is positive. It looks like 7 goes into both, right? What about a variable? Yep, a y. Awesome. Okay, so let's see what we got. So out of the first pair, we're dividing both of them by a 4x. So what remains when you take a 16x squared and divide by a 4x? Go to 4x. And yes, plus, what happens when you do the second division? You definitely get a 7. Looks like the x's cancel and a y. All right. Now out of the second pair, you took out a positive 7y. So when you do this first, yeah, 4 and an x, and it looks like the y's cancel, right? Good. When you do the second division, certainly is positive. 49 divided by 7 is 7, and an extra y left over. Okay? So it looks like the 4x plus 7y was distributed to another 4x plus 7y. Cool. Or, that's right, you can write it as the quantity of 4x plus 7y squared. Good? Awesome. Hang in there. Got some more of these special products for us. Okay, so before I get to the next type of special factoring, I want to look at this problem over here, and I want to distribute it, okay? So, again, when we distribute this, let's make certain we write every single line. So this first term of 3x will be distributed to the parentheses of 3x minus 2, correct? And then this plus 2 will also be distributed to that second parenthesis of 3x minus 2, correct? Okay, then we distribute. So we end up with a 9x squared minus 6x. And then on the second distribution, a positive 6x minus 4, right? Okay, I'm going to write a next line that we usually don't write, but in this case it's going to be important for us to do it. So we have 9x squared, and when I add these, it's a 0, isn't it? So technically it's plus 0x minus 4. But we usually don't write the 0x in the answer. We normally write the answer as 9x squared minus 4. Cool? Okay, so now, let's go backwards. So, now I want to factor. And the problem I am factoring is this 9x squared minus 4. So technically, the first thing I have to do is take these two terms and expand it to three terms, because the two terms came from those three terms. With me? Which means, since they don't have an x in the middle, I need to put a middle term, and I need to put a positive 0x to the power of 1, because 1 is half of 2, remember what I said in the previous lecture, and minus 4. So in this case, I have to take the two terms and expand it to 3, which means I need to put a 0 in the middle because that's where it came from. And now that I have 3 terms, I've got to take these 3 terms and I've got to expand it to 4 terms, don't I? Okay, so how do we do that? We take the first number, which is 9, multiply by the last number, which is negative 4, which gives me a negative 36, doesn't it? Okay, remember what I mentioned on the previous two problems. First term's a perfect square, last term's a perfect square, the product is a perfect square, so I'm looking for the square root. So what's the square root of 36? 6. So positive 6 times negative 6 in this case, because I need to multiply to a negative 36. Yeah, and it doesn't matter if you switch it around, it's still the same combination, so don't worry about that. So, 99% of the time, that's the combination that works for us. Does it in this case? Sure, because a positive 6 plus a negative 6 is a 0, isn't it? So, I can write this as 9x squared minus 6x plus 6x minus 4. Can't I? You're like, wait, you switch these guys around. Remember, it doesn't matter the order that I add those. I'm going to get the same answer. Remember that. So I just found my 4 terms, didn't I? Yay! So now that I've got 4 terms, now I got to go back and break it apart. Good. So, pair up the first 2, pair up the second 2, right? So out of the first 2, take out a 3 with an x. Second 2, because that's positive, I'm taking out a positive what? 2. All right, so first pair, taking out a positive 3x. What remains when you divide it? That's right, 9 divided by 3 is 3. X squared by x is x. Oops, a funny looking x. And then this minus 6x divided by 3x, minus 2. Good. With me? Okay. Second pair, taking out a positive 2, right? And then, yep, that gives me a 3x when I divide, and a negative 4 divided by a positive 2, negative 2. And now I'm noticing that this 3x and this positive 2 were both distributed to 3x minus 2. And that was the original problem, wasn't it? Make sense? Yeah, the only difference between this factoring and the 2 we just did was I got to take 2 terms and expand it to 3 terms. And the way I do that is I need to put the 0 in the middle because technically that's where it came from, right? This was the order of the multiplication. And I know we don't normally write this line, but if we write this line, we see that that technically was a 0. We just exclude it because anything plus 0 is just itself. Good? Okay, so hang in there. I got a couple of problems for us to work on. Okay, so let's look at problem number 3. Directions are to factor, right? Notice, well, first, we look for anything in common because we try to reduce it, right? Can I reduce it? Nope. And then I have to make sure it's in descending order. It is. Notice I have 2 terms. So based upon the example I just did, we have to take 2 terms and expand it to 3 terms, which means, yeah, what goes in the middle? That 0 goes in the middle. Remember that, right? So we have 16x squared plus a 0x minus 1. And now I've got the 3 terms, which I have to expand to 4 terms. And how do I do that? Just like I always do. We multiply the first number times the last number, and that gives me a negative 16. And I'm noticing the first number is a perfect square. The last number, which is 1, is also a perfect square, and it gave me a perfect square. So what's the combo you're going to try? The perfect square root combo, which is, yeah, a 4 and a negative 4. Cool? And gratefully it works, because 4 plus negative 4 is that 0, isn't it? Okay, so let's see what this looks like. So we have a 16x squared, right? And we have a minus 4x and a positive 4x and a minus 1, right? Remember, it doesn't matter the order in which I write these. I just decided to write it in this order. Are we good? So 2 terms went to 3 terms by putting in the 0. 3 terms got expanded to the 4 terms. And now break them apart. Okay, so I'm going to take the first 2 and pair them up, and the last 2 and pair them up. Out of the first pair, what can we factor out? Good, we can factor out a 4 and an x. And out of the second pair, yeah, because this first term on pair number 2 is positive, you're taking out a positive. A positive what? Some of you are like, there's nothing in common. You know, there's always something to divide out. I can't take a variable out, but there's still a number I can divide out. What can I divide out? A positive 1. Yeah, there's always something to divide out, even if it's just a 1. Got it? Okay, so the first pair you decide to take out a 4x. What remains? What's left over when you do this division? Good, a 4x and a minus 1. Excellent. And on the second pair, you decide to take out a positive 1. And what's left over? Yeah, 4x divided by 1 is 4x. And a negative 1 divided by a positive 1 is still a negative 1. And so now I see that this 4x plus 1 was distributed to the 4x minus 1. Cool? Okay. What about this one? Problem number 4. What's the first thing you're going to do? See if you can reduce it. Do you notice anything? Yeah, I noticed a 2 goes into both of those, but there's a larger number than 2. And when I divide, I want to try to divide out the largest number. Yeah, both of these will divide by a 4. So I can factor out a 4 and what remains. I know you got your calculators out. Good. 16a to the second minus 25. Excellent. So just like before, you're just going to hold on to that 4 and leave it alone. And you're going to take these 2 terms and you're going to see about factoring that 2-term polynomial. But remember, you have to expand the 2-term polynomial into a 3-term polynomial, which means you're going to write 16a squared plus 0a minus 25. Good. Excellent. And now what? Yeah, you're going to take the first term, which is 16, multiply it by the last one, which is a negative 25. What do you get? Negative 400. Oh my goodness, that's a lot of combinations. Wait, what's that you say? Aha, you're like, the 16's a perfect square. The 25's a perfect square. That means 400's a perfect square. So what's my combination? Good, 20 times a negative 20. That multiplies to a negative 400, and gratefully it adds to the 0 in the middle, doesn't it? Okay, which means we've got 16a squared, good, plus 20a, minus 20a, minus the 25. And then break them apart. Good job, you guys. You're doing excellent. Loving it. So pair up the first two, pair up the second two, or group them. I know that's the word that's used. Anything you can divide out of the first pair? Yeah, you can take out a 4 and an a. Out of the second pair? Yeah, because that's a negative for the first term, I'm taking out a negative. A negative what? 5. Good. So, the first pair, we're taking out a 4a. Tell me what remains. Yeah, a 4a plus 5. Good. Excellent. Out of the second pair, you said to divide out a negative 5. So when you do that, yeah, negative divided by negative is positive. Good. That'll be a 4a. And what about a negative 25 divided by a negative 5? Good. Positive 5. So, do you see it? It looks like the 4a minus 5 was originally distributed to the 4a plus 5. Awesome. Is that your final answer? Good, it's not, because you still have this 4 that you took out in the beginning, which means the final answer has the 4 in front of it, doesn't it? All right. Now, I'm going to tell you, the authors of the book will approach these last two problems a little differently. They'll give you a formula to go by, and it's kind of like a shortcut. Now, here's the deal. I personally don't like showing shortcuts because sometimes people mess them up because they don't know where they're coming from, so they don't really understand the shortcut or the formula. If you like it, fine, use it. But I really suggest approaching these last two problems this way. The first two problems I did, problems 1 and 2, again, they've got a formula for it. So if you want to use the formula, be my guest. But again, if people try to use a formula, they might get lost with it. So my suggestion for all the problems that I factored in this section is to use the exact same approach in a previous video lecture I did on factoring trinomials. Because really, if I just understand that factoring process that I did in the last video lecture with trinomials and apply it to these 4 problems that I did just now in this video lecture, there's never a new process you have to learn. Got it? Okay. There is one, but we're not covering it in this particular lecture video. In another class, you may have to do it. That one requires a formula. But all the problems I did in this video lecture and the last one, all of them use the exact same process that I've used in these 2 videos. So, hopefully this makes sense to you. Hopefully you realize factoring is not so bad. And as always, have fun with this stuff. Really, have fun with this stuff. And I'll catch you on the flip side.